Day 33, Part 3 Notes. It says at the beginning to go over what happens in each task of the lab. So, very quickly, we have a medicine dropper of rubbing alcohol, and we put it into the little water bottle, and then we cork it up. Please be gentle as you do this. You don't want to twist and break the needle that's in the cork. Shake it up a little bit, and then pump it just a couple times. And then when we release the cork, a little bit of cloud forms. You can see puffs when I squeeze the bottle. So what's happening there? When I shake it, I make some of the rubbing alcohol in the bottom evaporate and fill the water bottle with invisible vapor of rubbing alcohol. And then I pump it up to a high pressure, and that quickly comes to an equilibrium temperature with the air around it. When I release the pressure from uncorking the bottle, then the high pressure rubbing alcohol vapors expand into the air. And that expansion is a cooling process. It cools down enough that the invisible vapors of rubbing alcohol cool and condense into tiny, tiny droplets in the air. And those droplets are seen as the cloud. So that cloud that we saw wasn't the same as the clouds in the sky. It isn't made out of water. It's made out of rubbing alcohol. But the key point here is the rubbing alcohol vapors expanded and cooled to form the droplets. When warm air rises, it goes to higher elevations with less air pressure. And so as the warm air rises, it can expand and cool. As it cools, it can cool to a point where the water droplets form around dust and such and form a cloud. Okay, the second task that you had was to mimic the water cycle. We had a hot plate here that made a pan of water hot. The water then evaporated, turned into invisible water vapor, and floated up and hit the ice. This cool saran wrap then lowered the temperature of the steam, so the air could not hold as much water vapor as before because it's cooler, and it forms water droplets on the bottom of the screen there. And so we have condensation on the screen, and then if you're lucky, you have drops going back down into the water, and that's precipitation. So the water cycle has three parts: evaporation from some kind of a heat source, condensation up higher when it cools and condenses into water droplets, a cloud or whatever, and then precipitation when it falls back down into the surface layer, either falling as rain or snow or sleet or hail or whatever the postman doesn't like. So that was the second task of the lab. Okay, now let's look at the notes. Line number 1. Air blowing over mountains is forced to rise up. Line number 2. As air rises, it cools. Line number 3. As the air cools, the air can hold less water vapor. Eventually, air may cool until it can't hold any more water vapor that's in it, and this is called the dew point. The dew point temperature. When this happens, line number 5, when this happens, water collects on condensation nuclei. Condensation nuclei is a fancy term for just dust particles, maybe smoke, ions, even bacteria, stuff that's floating in the air. Water can collect on that when the air cools to the dew point. The dew point is a temperature at which dew forms on the grass during the summer. Number 6. When it condenses on this condensation nuclei. It might be liquid water that's condensing, or it might be ice crystals that are forming on these dust particles. Ice crystals. And clouds form when we have collections of these. So we have lots and lots of ice crystals or lots and lots of liquid water drops on these dust particles. That whole collection makes up the cloud. Number 7. When the droplets collide and stick together, they grow to be heavy enough to fall as rain or snow or whatever. So up here, I'd like you to draw the little diagram. I have a picture of the mountain. First of all, draw an arrow going up the side to go along with lines numbers 1 and 2, where air is blowing over the mountains and cooling. And then draw the cloud on the left side of the mountain, showing that as the air rises and cools, it forms clouds. And then show lots of rain coming down from the cloud, because as the cloud droplets get bigger and bigger, and as they collide together and stick together, eventually those droplets are going to get so heavy that they fall. That was line number 7. Line number 8. When air blows up and over mountains, one side of the mountain will get lots of clouds and lots of rain. Lots of clouds and rain as the air moves up and over the mountain. Line number 9. After this happens, then the air dries out after all the rain. Air comes down the other side, and it compresses as it gets to lower and lower elevations. There's more and more air pressure, so it gets squeezed a little bit. This causes the gas to heat up, and no clouds are going to form at this point. We need air to cool down in order to form a cloud. As it's descending the mountain, it's actually heating up. Number 10. The downward side of the mountain gets no rain. Deserts have this side of the mountain. This is called the rain shadow. Number 11. Clouds at the ground level are fog. We've covered that several times. And line number 12. If air does not cool to the dew point temperature, then no clouds will form. You have to have the temperatures get low enough so that the air contracts enough, gets squeezed enough, that there's not room for the invisible water vapor anymore. And so the water vapor has to form droplets or ice crystals on these floating dust particles in the air. And that will form a cloud. Okay, that was line numbers 1 through 12. Turn the page. And it says to watch a video. Why does it really rain in Seattle? So let's look at that. I'll shine my camera on the screen.
Okay, really quick, what's the first thing you think of when you think Seattle? I'm gonna take a wild guess and say that you said rain, maybe? That's even what Me From the Past said. But does it really rain that much? I mean, I know this because basically everyone who I talked to before I moved over here said, oh man, you live in that place, it rains so much. Jeez, who wants to put up with that? I mean, yeah, it rains here like it rains in any other place, but it's not that simple, I swear. Let me show you. So first, let's start off with a quick geography lesson. We are here in Seattle, Markberry School Star right here, and it's right next to this weird cat-shaped island, so I'm just going to go ahead and make it a cat. I don't know. It seems like the right thing to do right now. To the north of Washington is, of course, Canada, America's hat. To the south is Oregon, the place where all the hipsters go, and Idaho to the east. I don't really know what to say about Idaho, so we're just going to move on from that. And to the west is the Pacific Ocean. Striking almost right down the middle of the state is the Cascade Mountain Range. Many of the peaks in this range reach well above 10,000 feet, and that includes Washington's tallest point, Mount Rainier, at 14,410 feet tall. Okay, let's start off with Seattle as a small-scale example. And don't make fun of my drawing, I know it's amazing, okay? So when storm systems move in from the Pacific Ocean and travel over Seattle and the Puget Sound region, they come into a huge barrier with the Cascade Mountains. These storm systems, in order to make it over the mountains, have to break apart, and a lot of that leftover moist air condenses and rains down over the Puget Sound. This, on a macro scale, can create a very large band of annual rainfall and snowfall over the Cascade Mountains and a lot of the region to the left of that mountain range. After depositing a lot of its moist air in the form of precipitation over the mountains and in western Washington, there isn't a lot left for the eastern half of the state, and what gets created is this very large desert-like region in the area. This area is known as the Pacific Northwest Rain Shadow. However, winds called jet streams also play a big role in how storm systems move. They don't just happen in one direction. For example, there's a northwestern wind that comes in and actually splits around the Olympic Mountains. This area is called the Puget Sound Convergence Zone. Add to that fact that the Olympic Mountains create their own rain shadow, and you're creating a region that gets a lot of variable rainfall year-round. So yeah, it does rain in Seattle, but believe me, it's complicated. Thank you for watching this video, and if you loved my amazing art skills, go ahead and hit that like button and subscribe if you already haven't. And until the next one, I'll see you in the future.
Okay, let's finish up the notes here. So, why is the Pacific Northwest so rainy? There is actually so much rain in the Northwest that some areas are considered rainforests. The main reason is that most of the weather comes from the ocean to the west. As it moves across the warm ocean, it picks up water vapor. Then it hits land and is forced up by many mountains along the coast. As air cools as it goes up, it can no longer hold so much water. Rain is squeezed out of the air, sort of. When the air gets over the mountains, it's much drier air. It does not rain much on the other side of the mountains. Deserts often occur on the other sides of these mountains. This is called the rain shadow. Okay, now, another topic. Types of clouds that can form. 3 basic types. One is called cirrus. That's C-I-R-R-U-S. One more time. C-I-R-R-U-S. These are the really high, wispy clouds. We don't get much rain or snow from these. They're made out of mostly ice crystals, and they can be as high up as the stratosphere. They're the only kind of cloud that can appear in the stratosphere. And once again, they don't really rain. They just evaporate into the air once in a while. Number 17, cumulus clouds. Those are the puffy clouds. Cumulus is spelled C-U-M-U-L-U-S. One more time. C-U-M-U-L-U-S. These are the puffy individual clouds. If they rain, they give us short showers only, just a few minutes. Because there's a lot of space in between these things. They're not terribly huge. They do not cover the entire sky. The kind that cover the whole sky are called stratus clouds. That's spelled S-T-R-A-T-U-S. One more time. S-T-R-A-T-U-S. These are the gray clouds that cover the sky from horizon to horizon. Sometimes we get just a short shower out of these things. Sometimes it's an all-day rain. It all depends on what the conditions are. So use those definitions and try to come up with the names for the pictures. What kind of clouds are shown in each one of these pictures? Pause the video at this time and challenge yourself to try to identify each. Go ahead and write the names underneath each picture. Okay, I'm going to assume that you just unpaused the video and you're ready to see the answers. The first one, number 19, is cirrus. We can see they're kind of smeared out. That's going to be what we mean by wispy clouds, as if it's a cotton ball that's been stretched. And then we have cumulus clouds. Very puffy, very large in this case, but still it does not cover the entire sky from left to right. Looks like a giant cotton ball. And then line number 21, that is going to be a stratus cloud. It's just gray from one side all the way to the other as far as the eye can see. Number 22, these are individual puffy clouds. So these are cumulus. Number 23 is just one big gray bank of clouds. So that's going to be a stratus cloud. And then the last one, again, wispy, like they're smeared out. That's going to be a cirrus cloud. Now, there are other names for clouds, combinations of these words plus other prefixes. I have a note up here above the pictures. We have words like nimbostratus, altostratus, cumulonimbus, and other such things. The nimbostratus and altostratus are going to be just like a stratus cloud covering the whole sky. It's just that they're at different levels, and that's not important to know these prefixes. Just whenever you see the word stratus, you know that's going to be covering most of the sky, and we have lots of rain from those things. Cumulonimbus, we have the cumulo kind of a prefix, so that's going to be a cumulus cloud of some sort. The specifics, not important. Okay, next we have the wrap-up question sheet. Would you please take that, tear it out, put your name on top, answer the question, and put it in the blue box before you leave. If you have additional time in class, please look at the videos that are listed on the page 3 of yesterday's packet. It's a day 32 packet. I have a whole bunch of videos listed there about different strange clouds and how they form, perhaps. It's mostly fun stuff, so I hope that you'd spend some time looking at that. Thanks again.